What's up guys, this is Professor Spawn. In this video we are going to see about what is an hash table as a data structure before implementing the hash map. So what is hash table? Without wasting time, I will jump right into the topic. So we have seen about the array list, right? So we have seen about the array list as well as we have seen about the linear data structure called as a linked list. So if you notice, this data structure actually holds only one type of data, right? One type of data, right? In array form, right? In an array form. So basically what you did is you actually initialize, let's say, an array list of integer as well as the linked list of string or whatever it is, right? So this actually holds only one type of data. It's a linear data structure, but there is one more data structure which is called as a hash table, and it works in key value pair. So today we are going to see about the hash table, and this actually works as a key value pair, right? So whenever you want to store a data in such a way that want to store the data like in a key value pair. For example, let's say that you want to have a key as a name of the person and the value as a let's say phone numbers. So a phone book is a good example for this hash table. So basically hash table is also a dictionary where you can have a key and you can have a value. And the advantage of using this hash table is if you want to get, uh, let's say that you are maintaining a phone book and you want to get the value for John's phone number, right? John's phone number, you just do the get operation here, and this operation will actually return the phone number for John, right? And this operation happens in O of one time, or rather a constant time. So this is one of the biggest advantage of using hash table, right? The first thing first is, if you have a requirement where you want to store data in such a way that it should be a key value pair, you should always use this hash table. So we are going to see the implementation for the hash map in the next tutorial. But before that, I thought that you should know how hash table works. So I'm going to move into a new page and I will show you how hash table actually works, right? So what I'm going to do is here, I'm going to create a column. So for example, I'm sorry for this bad lining. So I'm going to remove this and I'm going to again create a column here. So just forgive me for this, right guys? So I'm going to create a column, and inside this I'm going to have a key and I'm going to have a value, and this is basically a memory location, right? So for example, you declare in a hash table, right? Hash table, let's say it's of type key, and then you have a value, right? So this is a generic. Inside this generic you have a key and then you have a value. Let's say that you are storing a phone number for John, right? So this is a string, and you are actually storing a John phone number, right, inside this hash table, right? So this is our hash table. So I'm going to name this as hash table, and it has keys and it has values. And let's say that John has some phone number called as 123. So a key is a type of string, value is a type of integer, right? So you can have that. So key and value can be of different type, it can be of same type, doesn't matter. So what happens is, whenever you want to store some entry inside this hash table, this John's is a key, right? So what will happen is, it internally hash table will calculate the hash for this key, and the return type for this hash is an int, right? So this hash function will actually return a hash value for the key. It is an int. This is basically kind of a memory address, and whatever hash we have, that hash will be stored here, right? So for example, we get an hash value as, let's say, 1. So at 1 we will store here the value of, let's say, 123, because John is storing here, and we will have here the key John here, right? So there will be a hash value of, you know, John. So I'm going to just write J here, for example. And let's say the second value you want to add is Henry, right? You are adding an Henry with a phone number of, let's say, 456. So the same process will happen. It will calculate the hash for this Henry, right? For this key Henry, and whatever hash will be calculated, let's say the hash for this is 3. So this will be stored here. So a hash for H, and the value 456 will be stored here. So this is quite simple. Now what you are doing is you are doing here a put operation. Now you are doing here a put operation. What happens? Now you have stored the data inside a hash table, and now you want to get a value for let's say for John. So your manager comes and says that, hey, just go and find the phone number for the John. So what you'll do is you'll use this hash table, right? The instance or object of hash table. So I'm just going to call this as hash table, and you will say that you'll do a get operation with a key of John, right? So whenever you do a get for the key, internally it will calculate a hash for this John, for this key, and whatever hash will return, it will actually get the value, right? So it will point to this table here, and if this hash of John matches with this hash of John, as both are same, so hash function is same across, right? So for John it will be same, so this will return me the value. So this is how the get operation works in hash table. But there is a problem, right? So I'm going to discuss the problem into a new slide. Let's say that you have added John. So I'm going to write here, right? Again, I'm going to draw that, and I'm going to draw here a table, right? And you have here J, let's say for John, with a value of 123. And now you are trying to add, let's say, a Johnson, for example. This is just an example with a phone number of, let's say, 789. And if you calculate the hash for this function, right, for a hash for this k, and it comes out to be 1. And if you notice, this key is different from the John key, right? But the hash function can collide. This is called as collision. This is a classic problem in this is a problem with hash table, right? This is a problem with hash table. We can have collision, and this collision, as the hash for this Johnson is same as the John, so what will happen is, instead of replacing this, what will happen is this J, the hash table internally actually implements some kind of array. So prior to JDK8, it used to be linked list, right? So here we had a John with, let's say, a data, then pointer for a Johnson with the value of 789. And again, if some third value collide with some third values hash key collide with the John's hash key, then we used to have a linked list here. But since JDK8, we we do have a linked list, but up to a certain size, up to a certain, a size, and after that it actually gets converted into a binary tree. This The reason is that the linked list, if you want to get a value, let's say that this linked list grows to, let's say, n values, and you want to get the value at n position, so this will happen in O of n time, right? Ideally, the hash table, if you want to get a value for, let's say, any key, this happens in O of 1. But due to collision, if this linked list grows to, let's say, some bigger values, and you want to get the value at n position, then this O, rather than having a constant time, we will get the value at O of n time. So when this linked list grows to, let's say, to a large extent, so with binary tree, this O of n gets converted to O of log n. So this is logarithm time, and this is much better than a linear time. So this is all about, the hash table is. So hash table actually stores the key, right? A key value pair. We calculate the hash for the key. We store that into a memory with a column as a hash of the key along with the value. And if you want to get the value for the key, so we calculate the hash and we check for where is that hash exactly, and then we get the value. So this is all about the hash table. In the next tutorial we are going to actually implement the hash map, which actually is a hash table itself. So we'll catch you up in the next tutorial.